Very good. So here is the outline for the day. We're going to talk about this whole thing is going to take place on the command line. There are GUIs for Git, but none of them give you a thorough enough understanding, in my opinion, to be very good at using it. So we're going to use the command line the whole time. So first we're going to go over bash commands and some basic setup. We're going to set up some presets the way I like it because it makes my life easier, and I hope it will for you too. And then we'll get right into all these things. Right around here we'll have a nice break so that you can go to the washroom and practice your skills and stuff. But until then, we'll dive right in. So my name is Matt Welk, and I'm a graduate student here doing computer engineering. I've used Git for probably 5 years or something now. It's really wonderful. And I'm also the technical lead for the UMSATS group, who's one of the groups that's sponsoring this event. The other is UMIEEE. I encourage you to join them both because they're very awesome. So the purpose of this workshop is mainly for UMSATS members because we're going to be using Git as the main software control system. But anybody's welcome to join. You don't have to feel pressured to join UMSATS at the end. But if you want to be part of building a satellite, then it's really the only option. This will take about 1.5 hours, maybe a little longer, depending on how many questions there are. And the idea is to learn the basics really, really well, and you'll practice them. And then I'll give you an overview of the more advanced things in working with remote repositories and things like that. So feel free to help each other out. We'll have a few times where you should just practice and make commits and make changes to files and help each other out with that. Not everyone is quite as skilled at the command line as other people. So I hope you have the cheat sheet open, mattwelk.ca/git-workshop. You'll want to have it just ready to go so that you can use it as a quick reference. Because I'll basically only say things one time for specific commands, and then you'll just know where it is in the sheet and you'll reference it if you need it. So Git is a wonderful, wonderful thing. Its purpose is to show is to keep history of your project. So for instance, here is my thesis, and I've been using Git for it, and it's really awesome. And so you can see, I'll go to somewhere a little more interesting. You can see this is being rendered in the terminal. It's very lovely. Each one of these lines represents a commit. I have a little message that I've made specifically to describe the change I made. We have a little hash, which I'll talk about later, and the star just says that it's a commit. So for instance, here there's no star, no commit. Git is wonderful because you can do things like branching and merging back in, and you can do things like rebasing and other fancy things, which I'll describe a little later. So it's also a distributed content tracker. Unlike some other forms, it doesn't have a central server that you have to access to see differences. You don't have to always queue a server whenever you want to make a change. Everyone who's working on the same project has the exact same copy of it, and you make changes to it, and then you can swap them back and forth. For UMSATS, we will be using a server which will hold just the main version of it, which we can access, so you don't have to have your computers on at the same time, but it's not necessary at all. So Git, if you use it for nothing else, it's a really excellent undo history. You can think of it as just a big chain of changes that you've made to files, and you can go back in time and make branches and try different things. And it's useful for very large projects. So we'll be using the command line, and so now we're going to go over some command line things. So I hope you have your terminal open. And the first thing we're going to do is go over just the basics. So I'll tab back over. So the first thing you want to do is hit CD enter, and this will get you back to your home directory. And we're going to make a folder in your home directory. I hope that's okay with you, a little bit of clutter. But that's where we'll be working. So CD gets you there. So we're going to first make a folder for a project. So we're going to say make dir, which is make a directory. And a directory is just another word for a folder. So make dir, and we're going to call it Gitorial, because that's clever. So now, instead of saying cd to get to the main directory, we're going to cd into the new one. And you'll see that I didn't type this whole word. I typed GI and hit tab because in the command line, you can autocomplete many things. And I encourage you to use tab as much as possible because it'll make your life much easier. So my prompt perhaps is a little different than yours. It shows me where I am, but yours might not show anything. So how do you know where you are? You can hit pwd, which stands for present working directory, and it'll show you exactly where you are. If you're running Windows, this might not make sense because but Git Bash works kind of in its own file system that it made on your system, so it won't have c:\/ or any of that. But this is where you are. So if we hit ls, we'll see we don't have any files in here yet because that's how you show the files. And so we're going to make one. We are going to make a file called readme.txt using touch. And so now if we ls, we can see that we have a single file. My ls will look different than yours because I set my presets differently. It shows me all sorts of information, but you can see that a file is there. If you want to remove this file, you type remove. Now you get rid of it. You can see it's not there. You can move the file with mv, but it's gone, so I won't do that. And you can remove entire directories with the list that's on the cheat sheet that I gave you. To see, I'm quickly gonna make that file again. To see the file itself, you can either open up some GUI or you can type less file name and it'll show the contents, which are nothing right now. So now we're going to go into editing a file because that'll make things more interesting. So if you are on Mac or Linux, you can type nano, the file name, and then you'll end up with this nice little editor, which is very nice. So open that up. If you want to save, hit Control-O, enter Control-X, which doesn't sound like it makes sense, but it shows you at the bottom. Write out is the way you're saying save. You hit enter to say the file name, and Control-X to exit. And you'll be using this a lot, so you'll want to be familiar with that. If you're on Windows, type Notepad and then the file, and it should open up some window for you.
Do you have the instruction like grabbing anywhere? Because we're just starting the system. We have some problems.
It's on the website there. Yep. So another handy thing is you can use the up key to redo something you just did. So that's useful. We'll use the command git commit like this a lot, and so you can just go up through and use that as well. So now I'm going to give you a little bit of time to practice this, because everything we're going to be doing that actually uses Git will build on top of this. So we're going to take 3 minutes, and I want you to just practice making files, making directories, deleting files, and I want you to end up just with an empty Gitorial folder that you're working with. So have at. So now we're going to make your very first Git repository, your very first one, and I'll show you how difficult it is. Awesome, awesome. So run git init, and you will now have version control over this empty folder. Isn't that wonderful? So if you want to see, Git doesn't work with magic. It doesn't store files anywhere other than in this directory. So if you type ls-a, you'll see we have this new folder. We have this .git. And if you just type ls, you won't see it because it's a hidden file. But it contains all of the revisions of the files that you have. So if we type ls.git, we can see all the things that are in it. And we have many things, and these are cryptic, and they contain magic, but it's contained. And so we won't need to worry about any of them except config. Config is nice. What it does is it lets you do certain settings just for this repository. There's another config in your home directory, which we'll modify, but this one is just specifically for that. So for instance, if you have a project and you don't want people to be able to do fast forward merges or something, then you can set it there. But that's the only thing that's important in this folder that we're going to worry about. So, magic. So now we're going to set up some global variables. Just type them as I do. They're, yeah. So first we'll do git user.name. Oh, sorry. I'm going to start this on a new line, but you shouldn't. Global. Using that up arrow, good stuff. So the next thing we're going to configure is the merge style. Yeah, nailed it.
So this random, sorry, so it can be.
Maybe. Whenever you type git space L, you'll end up with this lovely tree. So there you go. I'll highlight it for you. There you go.
I don't know.
So a quick note on configuration. What I just made you do will affect all of your repositories on that specific computer, because we did it with because we did it with the global flag. If we wouldn't have used the global flag, it would be just for that specific repository, but these things are so useful that you'll want them. And if you do system, then you have to have admin rights, and it will affect everyone on that machine. So pretty cool. Also, whenever I type hash, that just means I don't want it to actually run on my computer. So don't type hashes, because it's a comment. It won't do anything. Cool. So now we're going to make your first commit ever. A little practice. There we go. So this is a command that you'll want to type basically all of the time. So much that I've aliased it for myself to something much simpler. But git status will show which branch you're on. It will show some information about the commit. And it will show between here, that doesn't show yet, your changes, or the files that have changed, and the files that have changed that you've staged, which will make more sense very soon. So, using either Nano or Notepad, open up a file called readme.txt, even though it doesn't exist yet, and type some things to start us off. And by now you're pros at saving, so Control-O, Enter, Control-X. And now you'll see that in our directory we have this file, and if you type less, you'll see the contents of the file. So we have something going on. Now if we type the all-important git status, you'll see all-important things. You'll see we have a new untracked file. Untracked means that Git doesn't know about it. you can do anything to this file. You can delete it, you can move it, and Git won't be keeping track of any of that because it's untracked. So now we can see there happens to be a nice little instruction. Use git add to track the file. So let's go ahead and do that. Git add readme.txt. So running git status again, we can see that this change is now going to be committed. It is now a tracked file because we've told Git about it, and it's also staged because it's a change to be committed. Another word for a change to be committed is just staged file. So anything that is staged, when we tell Git to make a commit, it will commit these changes. So we're going to do exactly that. We're going to say git commit. And we'll add that file. Beautiful. So you can see it gives you a little bit of information. Usually you want to pay attention to what it spits out. It's not just garbage, but it's useful. So you can see that we added this. We made a commit with a hash that I'll talk about. And one file was changed, and it was inserted because that was the same file. So now if we do git status, there's nothing there. There are no changes to our directory since the last commit. So git status always shows the changes to the files since the last commit. But if we do our nice git L program that we made, we can see those commits that we made. So you can see there's a bunch of information here. We have our message that we added. We called it added readme.txt. We have head, and what head means is that this commit is the one that you're currently pointing to. It's the reference. If you hit git status, it's seeing what's changed relative to this. Master is the name of the default branch, and we'll talk about branches later and how to make your own. But usually, for your very first file, we'll be on master branch, and then we have our hash, which I'll talk about later. And by later, I mean right now. So if you do git log-p, you can get even more information. And so don't be flustered. This is a lot to know here. But -p gives you information about what the change actually is. If you hit git log, it'll like git L, it'll just say the message, but this gives you more. So you can see when we set up our configuration, we put our name here, and every commit you make will have your name on it. We have our email address, which will be on every commit as well, the time down to the hundredth of a second, the message, and then it shows the file that was changed. The name could even be changed, so this is kind of redundant for us. And it shows what the change is. And it's a nice green because we told Git in our configuration to use color, which is wonderful. We love color. So now we're going to make a little bit more of a, I'll talk about hashes. Hashes. So each commit has its own hash. This hash describes the total contents of all the files at the point of that commit, including this message, me, the time, my email, and all the changes. Also, it includes everything that's been committed so far on the same branch. So this contains a lot of data. It's a hash function, and it's a very, very long hash function, which means that it is extremely unlikely that you'll ever have the same one twice. So unlikely that Git relies on this. So this perfectly describes your change. And you can refer to commits by typing this in. But you would never want to type that in because it's gigantic. So using our handy, I won't use my shortcuts, git space L, you can use this mini hash, which is 7 characters. And 7 characters is not a lot to type. So that's actually useful. So you'll be typing those in eventually to do some nice little things. So now we're going to do a bit more of an advanced, a more complex commit. So we'll open up that README again, and we're going to make some changes. In this case, let's add another line to the bottom with a spelling error. Yeah. Well, it was totally intentional. So we'll save that out. Git status shows us that we've changed it. But if I want to try to commit right away, it will complain at me because there's nothing commit. Nothing is staged yet. We've made a change to a file, but we haven't told Git that we want that to be included the next time we make a commit. So to do that, you do git add again. It's the exact same command, git add readme.txt. And now if we do a status, we can see that it is to be committed, which means it is staged. So the important lesson is that if something isn't staged, it won't be in your next commit. So make sure that you commit, or that you stage all of the things by adding them before you make a commit, or you might make a commit where only part of your changes are there and then it won't run for the next person because they're missing a whole function or something. So the process is make a change, add it, and then commit it. Pretty straightforward. So now if we look at our log, we can see some nice things, but we'll use mine because it's better. Oh, I didn't commit. Hold on. So git commit, we'll give it a nice message. Nice. Oh yeah. Totally nicer. And now in the log, we can see we have 2. They're both here. Very lovely. And if you do our nice one that we made, you can see that our tree is growing. We had our root at the bottom, which head and master used to be pointing to, but now we have this other commit on top. I'm going to make this higher so you can see it better. So we're currently on master, as you can see when you do git status on branch master. And so master is moving up and moving the head with it. So the head describes what the current files you're looking at are, and master is just kind of like a bookmark to that location, which will make sense later when we talk about branches. So now we're going to give you a couple minutes to go through this process of making changes, adding them so that they're staged, and committing them. And make a chain of like 4 or 5 different commits. Just keep changing the file, make lots of changes, go for it. Hello, all right. So now you should, like me, have a nice tree. Should be awesome. And we'll be working with this tree for the rest of the time. So this will be our base repository. So make sure when you're making commits, make them a logical chunk of code. Don't commit something that doesn't compile or like will mess someone up or just doesn't make sense on its own. Like do a complete logical unit of something and then switch. Like if you're changing the name of a variable, change them all, commit it, and then do the next thing. And feel free to make commits really small, like even adding a single comment. If it won't fit with the next thing you're doing, make it its own commit. That's totally fine. There are ways of like squashing your commits and doing all sorts of fancy things. So make as many commits as you want, and it won't hurt at all. So now we're going to looking at differences between files. So I want you to modify a file. Modded. And then add it. And then modify it again. And then look at your status and tell me if this makes sense. So we changed the file, added it, and changed it again. So in the same file, we have staged changes and unstaged changes in the same file. So it's not, when you're staging something, you're not staging a file, even though you type the file's name. You're staging the differences between it and the point of reference, which is a previous head. So if we want to see what these differences are, like say say we made a really important change and we staged it, and then we made like a less important change. We're not really sure. We want to see if it's important. We can see the differences. So I'm going to introduce you to Git diff. So if you just type Git diff, it will show you the difference between this and this. It will show you the difference between your current working directory, actually between this and what is already staged. And you can see the first thing I did was I added the word modded, and then I staged that, and then I added x2 at the end. And so you can see that the difference is this. Now if we type git diff staged, you can see the difference between what is staged and the previous commit. So all that is one thing, because all I've changed that I have actually staged is just this one thing. And then you can do git diff head, all caps, to see the difference, to see both differences. So you can see what is staged and what is unstaged and compare that to the previous commit. So you can see there's the word there and what I added. And so using diffs is very important. You can even use diffs to compare commits or compare trees. So we're going to compare just we're going to type two different hashes and see what the differences were. So we'll do this one and this one. 4, 8, 5, 6. Boom. And I'm actually going to do it in the opposite order because it makes more sense if you go oldest to newest. 4, 8, 5, 6. Cool. So you can see the span between these two, this and this, was pretty big. It's a whole bunch of commits, but it can summarize all those changes for you and show all of the things. So you can see that I added this, and I even made another file that I didn't tell you guys about. So you can see all of the changes in the last 3 commits that way. You can also use branch names. So you can say git diff master, and if you had a branch called feature, which I don't, then you could see the differences between what someone else has been working on and what you've been working on. And it'll show you all in that nice format with pluses, minuses, and colors. Very lovely. So that's git diff, and it's very important. So if we were to stop right now, you would be able to have a complete history of basically your logical undos. If we just stopped here, you'd be able to have this. You could see your changes over time, but you wouldn't be able to revert back to changes or to branch or to work on a bigger project. So the next thing we're going to work on is branching. After branching, we'll take a bit of a break, but we're just going to dive into branching right now. So branches are kind of pointers to commits. We're gonna make one and modify it, and then we'll see how much sense it makes. So if you type git branch, you can see a list of all the branches we have. There's one. It's green and it has a star beside it, which means it's the one that we are currently modifying. If you hit git branch and give it a name, it will make a new branch. So I made a branch called feature. And if we use our little graph we made, you can see that whenever you make a new branch, it will be wherever you currently are. So I was on master, and I still am, and I made with me a branch called feature. Whenever you want to switch branches, you type git checkout. The terminology is you are checking out a branch, and then you switch to feature. And you may notice that I'm using tab completion for like branch names and stuff. That's something you can enable later. There's a website link at the bottom of my Git sheet, but it takes some time, so don't do it now. But it's a very nice thing. So I happen to have in my prompt, it shows me which one I'm on, which is a little hack. I can show you the later at the end if you're interested. But otherwise, you can hit git status, and it'll tell you which branch you're on. I'm on branch feature. And you can see that these changes that were there are still there. Because master and branch were pointing to the same commit, it didn't need me to have what is called a clean working directory. What a clean working directory is that means nothing is changed and nothing is staged. It's exactly the same as the commit that it's pointing to. And usually you need to have a clean commit when you're switching branches, or else it doesn't know what to do with the changes. And we're going to talk about that a little later. You can do something called git stash to kind of store those changes so that when you come back you can keep working. But my recommendation is just make a commit. Whenever it says working directory needs to be clean, just make a commit, and then you can come back to it, and that's fine. So don't stress too hard if you're switching branches and it tells you need something to be clean. So now we're on our feature branch, and we're going to make a change to our README file again. We're going to call this feature added. Cool, awesome. And I'm going to show you a quick way of doing this. So usually you have to add and then commit, but if you're very confident, you can just throw an A in there, and it will first add everything and then commit it with a message. So feature implemented. Awesome. Cool. So now we have our first deviation of branches. We have master, which has gone up to here, and we have feature, which is the current one we're pointing to because it says head, and we've implemented a feature, which is very nice. So now what we want to do is we want, usually how you work on a project is the master branch is the one that everyone sees. So when you've completed your feature, you merge it into master, and then other people see it, and they merge it into their code and keep working. So we're going to merge our new feature into master. So the process for doing that is you first check out master, and then you merge in your branch. That's it. So when you merge, it's always merging into where you are. So we merged feature into master, and so master has updated, as we can see. Now master and feature are at the same place. Now these branches weren't very branch-like. It was more like a stick that needed some updating, and so this is called a fast forward. Yeah, I will show you an example of a non-fast forward merge from my thesis. Oh, I got rid of this. Awesome. So this beautiful thing is not fast forwarded. I made some changes on this branch, which you can see here. I made some changes on this branch, and I merged them together so that they could both work from here now. An important thing about branches is that the branch doesn't describe the entire link. It's more of something that holds up a branch. So for instance, this transitions branch doesn't really have a connection to these two. It's just something that points at this commit. This commit points at this one because it's the parent, and that one points at this, but it's just a link that's being held up by this transitions branch. This is important because if I delete the transitions branch and delete the one on the server, which is what origin/transition means, then this will fall and be available for Git to clean up and delete. So if you get rid of what's holding up your links, they will be gone. One thing about Git is that it's very powerful. People like it because it's very versatile and you can do whatever you want, but part of that is the danger of making your own mistakes. So be careful when deleting branches. If you're using the command line, Git will give you a warning. It will say you're deleting unmerged changes, and so that's what that means. It means you have a branch that is only being held up by what you're trying to delete. But if you wanted to delete it anyway, like if we want to delete, yeah. If we wanted to delete our feature branch, we could go ahead and do that. Gone. It disappeared. And this is how a lot of people use branches. Don't think of branches as permanent things. Think of them as a way for you to separate your work for a while until you merge it back in, and then you can get rid of it. So, and that's exactly what we did. We made a change, and then we merged it back in and got rid of our branch because we don't need it anymore. So that's what branches are for in Git. They're a little more versatile and a little more mysterious, but I hope it makes sense now. So now we're going to talk about merge conflicts, and I happen to be prepared with this conflict terminal I have open. And you can see I have a master branch and a feature branch, but they've deviated. What happened was, this is a scenario, I made it up, but what happened was that we had a nice first commit, and then I was working on my feature, so I made a commit, and it was really cool, I made some feature changes, and then I got someone else's code from master that had been pushed in. So this will happen all of the time for you. You will have other people making changes, and you'll make changes, and this is what Git is good at, is merging these things in. So I want to merge master's changes into my branch so that I can keep working with the newest code. Perhaps a colleague added a function that's really useful to me, and so I want to merge that into feature. So that's all I have to do. I have to get on my feature branch, so I check out feature, and then merge in master. Boom. Oh no, conflict. Auto merging didn't work. What happened was there was one line that both people changed. And Git is a little bit careful. It says if two people change the same line, then it's just going to let you try to work it out, because that's like it's not magic. And so you can see, if we do our git status, that this is the culprit. Any files that merged flawlessly would be shown as being staged already, and this one isn't, so we know that there's trouble in it. So I'm going to open my favorite text editor, Vim, and open this up, and we're going to see these changes. So you'll notice all these squiggly symbols. I didn't type any of these signals in. Git put those there for me. And what they mean is this is the head, which is right between this and these pipes. So this is the change that I was making on my branch, on the feature branch. Between this and the equals are the things that the master branch is working on. And everything in the middle is what they were both pointing at. It's the common ancestor. And one thing that we changed in our configuration was we said to use diff3. And diff3 gives us this middle one. This one, pointing at the right one now. Without this one, it's a little more difficult because you only see your version and his version, but you don't know how it changed. So how we fix this is we have to get rid of this line, we have to get rid of this line, and this line, all these funny ones. And we also have to put the changes from both in together. So let's see what happened here. So it started off as being, there are things written here, and I wanted to say there are some things written in here, but he wanted to say there are strange things written in here, sir. I guess he's being formal. So what we're going to do is we're going to add the formalness in, because that was probably important, and we'll add in strange here as well. So some strange things. And now we don't need any of the rest of this stuff because we have one that represents both changes. So we get rid of all the weirdness. Now we're ready to go. Write and quit. And in our status, we can see that it doesn't know we've made this change yet. So we can just say git add and then git commit. And when doing a merge conflict, it gives you a nice automatic message. So we don't need to use -m. We can just say git commit, and then it will open up in the text message or the text editor that we configured, and it has this nice message, merge branch master into feature, and it showed the file that conflicted, which is very lovely. So we save that out, and now we have our working directory is clean again, and we can see that they merged together. Isn't this lovely? So we have our nice automatic merge message, and it is the changes that represent both. So lovely, pretty simple to do. There are some user interfaces that you can set as your default for merges. So you can say like merge tool, and then if there is a merge conflict, it'll open up a nice GUI with colors and lines and stuff. But you don't need any of that. You just have to know what those symbols mean. And so that, if you look at the cheat sheet, it's all explained. Don't be intimidated. It's pretty simple stuff. So that's how to fix merge conflicts. Boom. So I'm going to give you a little chance to test it out. And we're going to take a bit of a break for probably 5 minutes so that people who need to go to the bathroom can. And feel free to practice merges. Make a merge conflict, edit the same line twice, and figure it out. When we come back, we're going to talk about the all-important working with other people. We'll talk about working with GitHub and things like GitHub. And we'll talk about tags, which are useful. And we'll talk about some fancy things in Git which allow you to change the course of time. So now we're going to move on to what is actually the most important thing when doing a big project, which is working with other people. And so we're going to talk about remote repositories. So an example of a nice place that people like hosting Git projects is github.com. And if you go to github.com/umsats, you can see the umsats project from last year. And it's all here. It's very lovely. You can click on it. You can see its activity basically halted in August because we went somewhere far away. But you can see the current state of all the files. You can switch branches to all these other ones. We didn't use tags, but they are here and available if you want them. And you can see a list of all the commits. Lovely. Also, there are fancy things like network graphs that show people's different contributions over time. So GitHub is a wonderful thing, and it's a nice place to store your projects. But to use it, you need to know a little bit about databases. So let's say you're in your repository, and this is my thesis again, because it's my main example. And let's say you want to, well, let's say I didn't have it here yet. All you have to do is hit git clone, and if you're on GitHub or something, there's just a nice link right here. Git clone, and then this. And then it will take that whole repository and all the changes that have ever happened to it, and it will put it in your directory. So it'll look like this. Lovely. The next is, say you're making changes, and other people are making changes, and you want their changes. It's really simple. You just hit git pull. And what git pull does is we'll go that. It takes the changes from the server, which is usually called origin. You can have multiple servers, but usually it's origin. It will take those changes in from all the branches, and it will try to update your current branch to be updated. That's if you use git pull. If you use git fetch, it will grab in all the changes, but it won't touch your branch at all. You'll just be able to see other people's changes. So how these changes look is we have the server changes. You can see origin master is here. And so let's say I just fetched in my changes. My master is probably way down here somewhere. Lots of things happen in the meantime. I would just hit git pull when I'm on the master branch, and I'd be zoomed right up to here, and we'd be able to keep going. Yeah. So that is git pull and git fetch. When you want to push your changes, you use git push. Git push. And it's important to do a pull before you push. Because if you push and your code if someone else pushed before you, it will say you're not doing a fast forward, so you're not allowed to. So what you have to do then is pull and merge in their changes, and then you can push. Because whenever you push, it has to be in a straight line. So for instance, I'm going to find a not straight line. If this was their code and this is where mine was, I wouldn't be able to push it because I would have to do merge first. So first I merge this part, and you can use the hash, but it'll probably have a name. You merge it in, and then you link it up so that it looks like a straight line. So before you push, it has to be like this. They made a change, you made a change, you merged in their change, and then this you put on the server. Yeah, so just pull before you push, and make sure your things are merged before you push onto the server. That's it.
You can't push a branch onto the server?
You can. In fact, I could do that right now because I have my example branch, Gitorial. So you do git push origin Gitorial, and then it will say, you made a new branch called Gitorial. And now we can see that we have origin Gitorial, which is a very nice thing, a very strange word to say so many times. So now I'm going to talk about tags. Tags are like branches, but branches tend to move and grow, and tags just kind of stick in place. So you can see I made some branches here because I was trying to debug. My code wasn't working in Firefox. It was really frustrating. So I went like here, and I saw, and I tested it, and I said, okay, it's working, so I put a tag. And then I found the first one where it wasn't working, or where it was still working, and the first one that broke it, and I tagged those. So if I ever want to go back and see what makes Firefox unhappy, I can, because there's a tag there. So it's different. It has a different purpose than a branch. You don't develop on a tag, and tags don't move when you make commits. They're just a way of pointing to a certain commit that's convenient later, so you don't have to type this out. People mostly use it for version numbers. Doing versioning, you would have, like, say this, everything worked really great here, and your API was fine. You would call this version 1 in a tag, and then whenever someone goes to GitHub, you can point them directly to version 1, and they can download that straight away, and they won't be working with your beta software or anything like that. So that's what tags are mostly useful for. The commands are on a cheat sheet, but if you hit git tag, you'll see a list of all of them. You can see how useful mine are. And if you want to add one, it's git tag a Gitorial tag. Ooh, message of the tag. So something important is to not name your tags, your files, your branches, or other things the same name. Make sure things are unique. Because say I have my Gitorial branch and I keep working on it and it points somewhere other than a tag, which is Gitorial, Git won't know which one I mean, and then your command becomes much longer and it makes no sense. So just keep names distinct and life will be much simpler for you for tags and branches and all those things. To push tags, it's just git push, throw tags along. That should work lovely. Oh yeah, 4. I didn't have those on the server yet. And so that's tags. That's all there is to tags. So the last section I'm going to talk about is changing history, changing the flow of time. And I'm going to go back here for that. So this section comes with a warning. If you change the course of history in a way that other people will be affected by, they'll be angry with you. So only change history for a branch that either only you are working on or one that isn't on the server yet. So first I'll talk about undoing a commit. First I'll make one that I want to undo. Oh, typo. Oh, man. Oh, that's so unfortunate. Blah. Oh, that's the worst commit I've ever seen. It doesn't have a good message. It's going to break my code. Awful. So I want to undo that. So it's not on my server yet. In fact, none of this is. As you can see, there's no origin/anything. So if I want to undo that commit, I have a couple of options. Let's say I did push it to the server already. It's already on the server, and I want to undo this horrible, horrible mistake. You can do git revert and then the hash name. Or I can probably just do this. Yeah. Cool. So that didn't change history. This is the only one in this section that you can do at any time. But it did the opposite of this onto it. So how my code looks now should be exactly the same as this. If I hit git diff this and this, we would see there is no change because this did the opposite of this as a new commit. So it didn't get rid of the commit. It just made it as if it hadn't happened. It's negative history. And what's lovely about this is you can undo this commit on top if you want. It doesn't have to be the most recent. If there's just one change that you don't want to have to type out all over again, you can just hit revert on that and it will add negative history. Now let's say we actually want to get rid of that. Say I didn't want to revert it. You can do git reset hard and then, oh, let's try this. Yeah. It's gone. It's totally gone. That's what we typed. We said reset hard to that. And reset hard is very dangerous. We're in the warning section again. This is dangerous. It got rid of that commit completely. That revert we did is completely gone. It disappeared. We reset all the way back. And we can reset this if we want, and it'll get rid of everything. But keep in mind that branches hold things up. So if we revert back to this will still be here because it's still holding on, but everything that is dependent on feature to hold it up will disappear. So these two will disappear and that will disappear. But this is being held up by master, so it's still there. So reset hard is how you go back one chunk or a whole bunch of chunks. Now let's say I still have this terrible commit. Let's say it was okay, but it wasn't complete. I wanted to add some stuff to it. I could make another change. Blah, blah, blah. Awesome. And I can commit it. But I can say amend. Amend. And so what that does is it pops up with my same commit message as before, and I still like it. And now there is no new commit. I just added those changes to the previous commit. I amended them. So I'm using commands that I haven't told you about. I apologize. But you can see that both of these changes are in the same commit. What I did to see it is, instead of typing the hash, I put diff head hat. And every time you put another hat, it goes one further back in history. So git diff head doesn't mean anything, because that's comparing my working directory to the commit, but I haven't made changes yet. But this says move another back in history. So it shows me that commit, and you can see both of those things, which is lovely. But instead, you can always just type the hashes in. That's no problem at all. So that's undoing commits. It should all be in the cheat sheet. If not, let me know. But it's available. And only do it on commits that are fully yours. So I'm actually going to get out my favorite tool, which is the old drawing tool. And we're going to show you a little something cool. And it's called rebasing. Rebasing. This is called GIMP. This is the GNU image manipulation program. Quite lovely. That's okay. So let's say we have this commit, and we have another one, and we have another one still. And this is where master branch is. Everything's good, having a good time, chilling on a master branch. And we have our feature branch, which we've been working on. It's blue. I apologize for everything being yellow. I could have actually changed that the whole time. There. Sorry. I really do apologize. It's good for the eyesight to see yellow sometimes. So this is my feature branch. And so if master keeps going and I keep merging in changes, I'm going to have like this chain-looking thing that's a bit unruly. It can make your tree look more like a spider web, and it can, even though you're keeping all of the information there, it's not really pleasant to look at. It's not quite as useful. So something I recommend you get into is rebasing. And what rebasing does is it changes history, as you might have expected. So instead of our feature branch, this is an F, instead of our feature branch coming from here, it changes it as if this is what actually happened. Yeah. So what it does is it takes these commits and redoes them on top of whatever you're rebasing to, which is almost always going to be master. So it takes this and it redoes it here, and if it doesn't work properly, if both lines have changed, you'll have to do a conflict, and then it tries to do this one on top, and if that doesn't work, there will be a conflict, which you'll have to get through. Now, my recommendation is whenever you see changes on master, try rebasing onto them. And the command is git rebase master when you're on your feature branch. Try rebasing, because what that'll do is you'll keep as much of time in a straight line as you can, and it makes it really nice when you do push your code, because you'll be pushing this line on top rather than like a bunch of webs and stuff. But my recommendation is if you have a merge conflict, give up. And I'll show you how to elegantly give up, which is the lesson of the day. So let's see if we can do this in real life. For C-A-C-19. Ha! Yeah, destructive. I got rid of half my tree just there, but I meant to. So we're going to try to do a rebase onto master. Actually, yeah, onto master, of course. Oh no, a conflict. So if we were to actually look at what the conflict is, we would be able to see there are all these things. Lovely, beautiful. But when you're rebasing, the thing is, if you changed one line a bunch of times, you'll have to keep doing merge conflicts, and this will use too much of your time. So instead, you want to just do a merge. But if we look at status, I'm like in the middle. I'm not currently on any branch. I'm in the middle of a rebase. I'm not part of the tree. This is weird. And to get out of it, you just do git rebase abort, and then you're back to normal. Lovely, everything's fine, and then you can do a nice merge. And of course it'll fail because it did before. And then you can edit just the simple things that you need to. I'm just going to use my changes because I'm lazy. Commit it, but I'll add it first. Beautiful, merged. So what I recommend we do for stats is you try to rebase. If you get any fail, give up and do a merge instead, because it isn't worth the hassle of doing like tons and tons of changes. So rebasing is awesome, and if you're ever working with, Like if you're on GitHub and someone is working on a big repository like the Linux kernel and you want to contribute, then you would want to rebase your changes and go through all that so that when they merge it in, it's just a line. Or you can even squash it so it's a single commit for them, which they like. Or even a patch, which you can email, which is crazy. You can email, whatever. So that's rebasing. It's something that's a little more unique to Git, and it's not commonly encouraged to edit your history, but it is in Git because it makes life better. Yeah, so a typical flow would be to pull in changes, to pull in changes, you try to do a rebase to master if anything's changed, and then if there's any conflicts, you do git rebase abort, and then you merge instead. And finally, you push your changes. Beauty. And that is the recommended workflow for sets. So that doesn't look too intimidating, does it? It's like 5 commands, no problem. It's all in the cheat sheet. I hope it makes sense. Don't push code that doesn't compile, because people will be very frustrated if they rebase something that doesn't compile and they have to fix your mistakes. So push things you're confident in to master. For sats, hopefully we'll have tests that you'll run on your code, and so you'll want to run your tests anytime you're pushing them to make sure it behaves exactly as you want, and it should work out very well. I'm very confident in the software. So to wrap up, I'm going to talk about a couple of technologies which are nice, and aliases. So you can type git k, and you get this GUI, which is a little bit intimidating, but you can flip through all your changes, and they show up at the bottom there. Git k, that was the command I ran, just git k. It's nice. You can flip through really quickly. It shows your tree. It's a beautiful thing. Okay, now I'm going to warn you, there's software called GitHub for Windows and GitHub for Mac. And those pieces of software will make you able to use GitHub, but they will limit you a lot, and they do a lot of things for you which, if you don't expect, could make you go a little crazy. So my recommendation is you can use GitHub for Windows to clone things and set things up on your hard drive, but don't use it as a regular, don't make it your workflow. There are many others. There's Giggle and other weird names for things. So you can find a nice GUI if you really want a GUI, but I think if you have that cheat sheet and you've learned something today, I think you'll be ready to go just with what we have. I put in a whole list of aliases at the bottom of the cheat sheet. For instance, git co I use for commit, or checkout and commit, and L we use this whole time. And I even aliased git to G. So when I'm working, I am very fast. And it's very, very simple. So those are all at the bottom. There's also a link for auto-completing names of branches. Boom. Boom. Too bad it doesn't do hashes. That'd be awesome. And for some further reading, you can check out git bisect, which is a way of going through your code in a bisection method to see where a bug is. And yeah, there are all sorts of links. So my recommendation is to go practice. Use Git for the next project you do. If you do anything that is in plain text, if it's coding, if it's a to-do list, whatever, put it in Git, test it out. It's lovely. Or your homework, if possible. Anything that's plain text. So thank you for coming. If you don't know about sats or you want to join, let me know. We have a QR code and we have human. Yeah, thanks for coming to the first Git Workshop. See you around.